Hi, this is section 1.2, and again, we're going to be continuing with our exploration of patterns. Now, the only difference between this section and what we've done before is we're going to add some formulas here to this section. So, these are going to be more patterns, but these are going to be very specific types of patterns. And if you've already had college algebra, which you should have, then you've seen these before. They were called sequences. So we have basically three very common types of sequences, and those are called arithmetic, geometric, and then the Fibonacci sequence, which is a recursive sequence. Those are very famous types of sequences. So let's take these one at a time and let's look to see the formulas that are associated with them and kind of some things about them to refresh your memory. So arithmetic sequences, these types of patterns of numbers happen by adding the same amount to get from one term to the next, to the next, to the next. So I put a few examples out here. So for instance, this very first set of sequence here is 1, 2, 3, 4, 5, 6, and on and on and on and on. So can you see that in order to get from one term to the next, to the next, to the next, to the next, what we're doing? We're adding 1 to get from the first term to the next term, and then adding 1 to get to the third term, and then adding 1 to get to the fourth term, and adding 1 to get to the fifth term, and so on and so forth. So that's what makes this an arithmetic sequence. The second one is also an arithmetic sequence. Can you tell what it is that we are adding to get from one term to the next to the next? Looks like we're adding 5, doesn't it? So that's what makes this an arithmetic sequence, because we're adding the same amount each time to get from term to term. Now what about something like this? We have 2, 6, 10, 14, 18, 22. What are we doing to get from term to term to term here? It looks like we're adding 4 to get from term to term to term. So that's what makes it an arithmetic sequence. So when we have patterns of this type, we call them arithmetic, and they have what we call a common difference. Now that common difference is this amount that you are adding to get from term to term to term. So for instance, in the first set there, we would say the common difference is 1. In the second set, the common difference would be 5, and in the third set, the common difference would be 4. Now we have a formula that we use when we're working with arithmetic sequences, and that formula is a sub n, so your a with a little bitty n, just a little bit lower than the a, equals a plus, and then in parentheses, n minus 1 times d. Now don't worry if you don't remember what that formula is. I'm going to go through all of the variables for you to explain it. So the first variable there, a sub n, that's what we call the nth term. So for instance, in my, let's say the second example here, the nth term would be like saying that this term is 0. So that would be the first term we would call is 0. The 5 is the second term. 10 is the third term. 15 is the fourth term. So that actual term itself is the nth term. Now a by itself is the first term. So technically we would call the first term in this example 0. N represents the how many terms that you have, or which term, maybe I should say. So let me explain that a little bit better. So in this case, and I'm going to do this in blue here, 0 is our first term, so n would be 1. 5 is our second term, so n would be 2. 10 is our third term, so n would be 3. 15 is our fourth term, so n would be 4. 20 is our fifth term, so n would be 5, and so on and so forth. Okay, and then our last variable there, d, that is our common difference. So in that second difference, did I spell that right? I tell you what, I can't think and write at the same time. That common difference is what we've just talked about here. So in that, again, in that second example, d, or the common difference, would be 5. So that's kind of a refresher on arithmetic sequences. Now we also have geometric sequences, and these types of patterns, they happen by multiplying the same amount to get from term to term to term. So before in arithmetics we were adding. In geometrics we are multiplying. So for instance, in this first example here, can you tell what it is that we are multiplying to get from term to term to term? And I shouldn't have that 0 there. Let me go ahead and mark that off. Sorry about that. I should have edited before I did this. So let's say that 2 is our first term here. So we have 2, 4, 8, 16, 32, and so on and so forth. So can you tell what it is that we're multiplying by in order to get from one term to the next? It looks like we're multiplying by 2. So 2 would be the multiplier, and that's what makes it a geometric sequence. Now this one might be a little bit more tricky. So 8, 4, 2, 1, 1/2, 1/4, and so on and so forth. Can you tell what it is that we're multiplying by in order to get from one term to the next to the next? Part of you may want to say, well, you're dividing by 2, but technically we're supposed to be multiplying by a number. So what we're actually multiplying by here is 1/2. Remember, multiplying by 1/2 or dividing by 2 are the exact same thing. So we want to put this in terms of a multiplication and not a division. Now, what about this next one? This one might be even more tricky. Think about what you're doing to get from 25 to -5 to 1 to -1/5 to 1/25. Did you come up with multiplying by -1/5? You might want to say here that you're dividing by -5, but that's the same thing as saying multiplying by -1/5. So we want to make sure and put that in terms of a multiplication. Now, we do that because it says when we have patterns of this type, we call them geometric, and they have what we call a common ratio. So that common ratio is what we're multiplying by in order to get from term to term to term. It just has that special name of common ratio. And again, like we did in the arithmetic sequences, we have a formula for geometric sequences, a generic and what we call the nth term formula, and it is a sub n equals a times r raised to the n minus 1 power. So now don't worry, let's refresh so you'll remember what all of those variables represent. A sub n, again, is the nth term. So if I ask you, like in this second example, what is the fifth term? Well, that would be 1/2. So in that case, a sub 5 would be 1/2. A, just like before, is the first term. So in our case, in this second example here, A would be 8. And then we have R, which is our common ratio. So that's what we're multiplying by to get from term to term to term. So in this case, it would be 1/2. And then we have N again, which again is, how many or which term. So, for instance, this would be, I'll do this in blue so we can kind of keep this straight. N would be 1 for the 8, N would be 2 for the 4, 3 for the 2, 4 for the 1, 5 for the 1/2, 6 for the 1/4, and so on and so forth. So N is the number of the term. The term itself we call A sub N. So A sub 6 would be 1/4. All right, now we have another type of sequence that we see pretty often, and these are called recursive sequences. Now, recursive sequences happen when you um, use the number before them, but they're not necessarily arithmetic or geometric. So but the most famous of these is called the Fibonacci sequence. And the Fibonacci sequence, which was made really popular in Dan Brown's book, The Da Vinci Code, in the movie. So they were, doing things with the Fibonacci sequence. So you may have seen that or heard that before. But the Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, 21, 34. And, let's just take a second and see if we can figure out, what's going on here. If you were to add up 1 plus 1, you get 2. If you add up 1 plus 2, you get 3. If you add up 2 plus 3, you get 5. If you add up 3 plus 5, you get 8. So each term is the result of adding the two terms before it. So each term is the sum of the two previous terms. So that's but you can see that is not arithmetic because you're not adding the same amount to get from term to term to term. And it's not geometric because you're not multiplying by the same thing. So that kind of falls into a different category. All right, so those are the three kind of basic general types of the most famous kinds of sequences. So now we're going to work some problems and see how those formulas and things can help us.